to see data. So the implementation time for all the applications going through a certain place is extremely short.
What about encrypted traffic?
Encrypted traffic can be handled in different ways. I mean, the first thing is that everything which is done at TCP level, which provides you already with a large set of data. So basically that was the first part of the first scenario, like figuring out if you've got a degradation, where a degradation comes from, where the people that have the degradations are located and when they are located. All of that you can get without decrypting the traffic. And then the solution also incorporates the ability to decrypt traffic for a certain number of protocols, and then we can also sit next to SSL inspection devices you would have in your gateways. So if you want, for example, to get visibility into cloud services, like as an example, Salesforce.com, if you've got an SSL inspection, we can actually track down to the transaction level. If you don't, we can still figure out exactly which users get what performance where and connecting to which servers and where problems are coming from. They are coming from the network layer or from the server response. Any other question?
I was just thinking that those are different applications there, so how do you identify those? Or is it a huge task to create such an application for the whole parameters for those?
The principle is that we recognize about 1,500 by default. So without doing anything, you just basically feed the probe with traffic and it's going to recognize it. And most of it is going to be made by a mechanism that we call PyPI, which is basically port-independent protocol identification. So whatever the port on which an application is run, it's going to be recognized as the application by application signatures. So that already provides, a wide range. And then afterwards, if you want, you can actually customize it. So if you've got a web application running on a specific URL or an HTTPS flow running with a certain certificate, you can actually also customize your application portfolio and name it, but you don't have to start using the solution. And the discovery will be automated. Oops, sorry.
That's okay. How do you identify performance anomalies? As in, how would you tell that something's actually happening to you?
Okay. To find out that there is a performance anomaly on a specific kind of transaction, you need to look back time and you probably need a baseline. So the first thing is retaining an history and actually being able to look at the normal behavior of a specific transactions. So the way we would do it, for example, if I take an example in, say, a database environment, for example, I'm going to take a common query. So just find one, just for the sake of the example. So if I take, probably I'm going to take a larger period of time to get a bit of volume. Okay, so if that, for example, that query happens, 3,000 times, it's easy to find out what is the baseline for that query. It's going to take between 10 and 20 milliseconds because you've got to look back time and you've got a reference, so you know how long it takes in normal. So probably if that query goes up to 40 or 50 milliseconds, probably that your server is actually responding worse. So that would be the first thing. The second thing that we have is we're integrating also a prediction engine, like artificial intelligence, which is going to basically